Briar, quiet. Okay, 6th grade, we're going to start with the warm-up. Our objective today is to go with it. Okay, but before that, we're going to review the types of numbers as well as perfect squares and simplifying radicals. Okay, so page 10 in your notes was the warm-up, and we're going to start with the types of numbers chart. Okay, I wanted you guys to fill it in. This is old, but we did this in chapter 1. So I didn't want to skip the lesson, but I don't need to teach you something we've already learned. Okay, so it should have been a good review warm-up. Briar, in the innermost circle, what type of number goes in there? Good, natural. And Briar, a natural number starts with what? Yep. Good. So a natural number goes in the innermost circle. It's a nice number, starts at 1, and it keeps going up. Okay, Matt, the next circle, what goes there? Okay, and what is a whole number, Matt? Good. All the way to infinity. So the only difference between whole is that it starts with a 0. MAH, the next circle. Good, integer. And can you explain what an integer is? Good job. So negative infinity to positive infinity, no fractions, no decimals, nothing like that. Okay, Jeremy, next circle. Did you do your warm-up? Okay. Make sure you ask next time, okay? Doug, next one. Good, rational. Doug, what's a rational number? Okay, what else? You're trying to say something else, but you're just not getting it out. So it could be a natural integer whole. It could be a fraction. What else can it be? Okay. What else? We already wrote that down. Melissa, what else? Good, repeating decimal. Donatus, what else? Good. So, hey, so what kind of square root is rational? The what? The perfect square type. So square root of 121. Okay, anything that's perfect is rational. Also, Mary, or Frodo, what? Good. And mixed numbers. So I just kind of listed around the rational circle so you don't forget what rational can be. And this will be part of your cumulative, so it is good that we're going back to this for a little bit. All right, and then the next circle, Annalise, should be what? Good. Everything in here is real. Okay, a real number is just not imaginary. But then within the circle, you guys have a little circle kind of hanging out down here. Justin, what goes in there? Good, irrational. Justin, what's the perfect example of irrational? Good. Pi repeats however it wants. It has no pattern. Besides pi, what kind of square root is irrational? Frodo. Good, non-perfect. So like square root of 113. A real number are all of these in the circle. Irrational is also real. Annalise. Yeah, you don't have to ask. It's over there. Okay. And then one more little circle kind of hanging out in its own little island. Manatee. Good. Imaginary. So, no, hold on, not Doug. Manatee, what is imaginary? Like, can you give me an... Good. So if you have something like square root of negative 27, I'll eventually show you how to use, simplify, and deal with imaginary numbers. Doug. And then I'll go to Emma. Mary. Okay. Emma H., go for it. Oh, because I should use negative 144? Okay. How come? Oh, I didn't know that. You have a good memory. I didn't realize I always use that one. Oh. For imaginary. Oh. Interesting. Okay. I'm impressed you guys remember those things because I didn't. Okay. Okay. I'll make sure I don't forget about those numbers because they like us now. Okay, questions on the types of numbers chart. Okay, flip over your warm-up, which was on page 11 of your notes. Okay, this was the number line. Now, the directions were wrong. All I wanted you to do was put the numbers in order from least to greatest. So I'm going to make this -2, -1, 0, 1, 2. Let's make this a 3. Okay, so Charles, what goes first, putting these numbers in order from least to greatest? Good. And that one I'm going to put over here. Okay, what goes next, Sean? Good. I'm going to put that one here. Briar, next one. Good. Wrong spot, I know. Justin, next one. Good. Emma M, next one. Good. Okay, so it doesn't have to be exactly perfect. Okay, there is? I forgot about him. Okay, last one is way over here. I know, sorry. I forgot about the 5. The last one is the 5. Now, I should really have 2 more tick marks there, 4 and 5. Annalise? That's fine. Yours is probably more organized than mine. That's fine. Roman numeral 2 asks us to compare the numbers and then tell whether they're rational or irrational. So let's just read through these ones. So the first one, Donatus, for 1/3 and -1/3, what did you put in between them? That would be greater than. Donatus, you know all this crazy stuff, but you don't know what's greater than and what's less than? Donatus! Every time I teach something, you're like, I already know how to do this, but you don't know what greater than is? Okay, Donatus, if the big side's going this way, look, it's greater than. Okay, Pac-Man's eating something. It's going this way. It's less than because it looks like the loser symbol. It looks like an L. Okay? There, I taught you something finally. All right, so the first one Donatus said is is greater than. Both numbers are rational. Okay, the second one should be less than. Square root of 3 is irrational. 3 is rational. Next one, Emma H. What's the symbol? 5/6 is what with square root of 5/6? Unless I messed up. Shh. Hey, listen, guys, you should not be talking. No, Emma, you are correct. I'm sorry. Where's your pencil? I'm going to steal all your stuff again. Emma, I apologize. She is right. Right, correct. Emma H is right. I messed up. So 5/6 is rational. Square root of 5/6 is irrational. The next one, Doug, -1.7 is what with negative square root of 8? That's not. Okay, -1.7 is greater than negative square root of 8. -1.7 is rational, and negative square root of 8 is irrational. It's not right. Do the decimal again. -1.7 is greater than, Emma. 8, square root of 8 is 2.8. So you probably forgot about the negative. No, we both messed up now today. Okay, Charles, square root of 25/16 is what to 5/4? No. Really? Alyssa, equal. Good, those are equal. Both of those numbers, Alyssa, are what? Irrational or rational? Good, they're both rational. Annalise, that last one. Good, it's greater than 3/4. On that last one, square root of 3/4 is greater than 3/4. Annalise. Yep. Right. No, it's the square root of 25/16. Once you take the square root's gone. Right. No. 5 over 4 is 1.25. They're equal. I would just type in second x squared, type in 25 divided by, oops, 25 divided by 16 and hit enter. You get 1.25. No, just do it once. That's the way it's written. Okay, let's go to the closing. Okay, the first one, Doug, rational or irrational? Okay, well, tell me. 6/7, is it rational or irrational? Yes. 6/7 is rational. The next one, Frodo, square root of 12. Good, irrational. Sean, -1/9. Good, rational. Justin, 0. Good. Emma M, -1.524. Good, rational. Jeremy, square root of 9. Good. We're not going to worry about plotting those on the number line. That one's rational. Good. Negative what? No, that's rational. Any fraction is rational. Questions on the warm-up before we go over homework? Okay, is everyone feel okay with types of numbers? Okay. All right, let's go over practice 9.2c first. Okay, see how this goes, then we'll go over the other one. All right, Manatee, you're up. 9.2c, which was page 144. Go for it. Good. Emma H, number 2. Good. 7 square root of 15. Frodo, number 3. Good. 8 square root of 7. Number 4, Donatus. Okay, I'll come back. Do you have it? Good. 6 square root of 3. Alyssa, number 5. Good. Much better than yesterday so far. Good job. Annalise, number 6. You should not be writing any of this. Put your pencil down. Okay, you're not just copying answers. It's not going to help you. Tell me 6 first. It'll be up here. Good job. Number 7, Emma M. Awesome. Briar, number 8. Okay. Number 8, Sean. Okay, one more step. 2 over 14 reduces to 1/7. So square root of 17 over 7. Okay, number 9 is square root of 3. Justin, number 10. Square root of 135 has 9 that goes into it. So there's a perfect square that divides into that. So 10 should be 3 square root of 15 over 16. Alyssa, number 11. Good. Good. Number 12, Manatee. Good job. Very good job. Emma H, what's your name again? Arwen. Okay, Arwen. I'm going to learn yours today. Arwen, 13. You're perfect, Arwen. Job. 14, Annalise. You forgot about the X and the Z that are not perfect, so they stay inside. Okay, so everything's right, but you need to keep that X and Z inside because they are not perfect squares. Okay, 15. Frodo, did you get to 15? Very close. You just forgot to take the square root of 4, which is 2. Okay, Arwen, so I don't forget your name. 16. Good job. Punishment for learning a new name. Alyssa, 17. One more step, 3 over 12 is 1/4. I would not mark that wrong, Alyssa, because you got the answer right. Just try. I want you guys to try to simplify. All right, 18, Charles. Well, that's not very good. You're kind of off today with this math. Nope, that's not right. That's okay. There's a perfect square that goes into it. Arwen. You're right, Charles. There's a perfect square that goes into 12. So, Alyssa. Awesome. Okay, Manatee, 19. No, square root of 2 over 3x. Annalise, 7 over 21 is 1 over 3. It reduces. Manatee. Okay, if you guys didn't simplify, I will not mark it wrong. Okay, because if you can simplify a whole radical expression but just not simplify, I will not mark it wrong. I'm grading you on simplifying the radicals, not fractions. But try to, Manatee. Okay? Okay, Arwen. Square root of 2 over 3x. You did? Okay, sorry. I don't know why. I was really listening. I don't know why I didn't think you said that. My fault, Arwen. You're good. Okay, 19 is 2w square root of 11 over 11. If you didn't simplify 19, it's 4w square root of 11 over 22. 20 is about 9 seconds. 21 is about 6 miles. And 22, the next two numbers, or the next three numbers, are 2 square root of 7, 4 square root of 2, and 6. 4 square root of 2 is the same thing as 2 square root of 8. 6 is the same thing as 2 square root of 9. But you guys should know how to simplify. 2 square root of 9 is 2 times 3, which is 6. So you guys with me? This is hard. 2 square root of 8, the 8 breaks down into square root of 4, square root of 2. So you get 4 square root of 2. That was a hard one. This is an honors type worksheet, but you guys are in honors class. So, Annalise. Mm-mm. And do you see the pattern, Annalise? No, it's what I have up here. So they all have a 2 in front, and then inside the radical is the next number. Did you figure out the pattern? So after 2 square root of 6 is 2 square root of 7. After that is 2 square root of 8. After that is 2 square root of 9. But 2 square root of 8 can be simplified further, and 2 square root of 9 can be simplified further. 5 should not be in there. 3 is not in there either. Yeah. It's only if they simplify. The pattern is 2 in front and then the next integer inside the square root, going up in increasing order. Okay? Emma. But 25 does not go into 735. What, 25? Take your calculator, do 735 divided by 25. 25 does not go into it. 49 is the largest perfect square that goes into it. That's all right. Okay, anyone else? Questions on that worksheet? Frodo? Number 20. I don't remember because I don't have my work on here. Hold on. I'll tell you in 1 second. Jeremy, you're messing me up. 4 went into it 345 times. So does that help you? I should write all my work out and I don't. Okay, Annalise, you had your hand up. What still goes into 44? What perfect square goes into 44? 4 goes into 44, so you're not done. You did not simplify completely. And then keep going. The reason that you messed up is you didn't find the largest perfect square. Yep. And then 4 over 22 reduces to 2 over 11. Okay. All you're doing is simplifying 500,000. So the square root, the square root of 50,000 is what you're simplifying. So you need to find the perfect square that goes into 50,000. I want you to figure that out. Nope, you're taking the square root of it. You're finding the side length, Annalise. That's the area of a square. They want you to find the side length. So it's 50,000 equals s squared. So you square root both sides to undo that. So there's many perfect squares that go into 50,000. Just pick one and start simplifying. If you don't get it, I'll kind of do it with you. You have to simplify it. Find a perfect square that goes into it. No decimals. You do what we've been doing with the perfect squares, okay? Frodo. Because it was square root of 345 over 2, they want you to divide it because they want you to approximate the value to the nearest second. So this is the only time they actually want you to change it to a decimal. Yeah, correct. Does that make sense, Frodo? Okay. Arwen, I didn't forget. All right. Anyone else on that assignment? Okay, let's go over page 140. You had 1 to 12, okay? Briar, number 1. Good. Charles, number 2. Good. Number 3, Jeremy. You don't have it. Arwen, number 3. Good. Manatee, number 4. Frodo, number 5. Alyssa, number 6. Good job. Donatus, number 7. Emma M, number 8. Man, you guys are good. Number 9, Sean. Briar, number 10. We'll do it. Square root of 16 over square root of 81. You don't need your calculator. What's the square root of 16? It's the square root of 81. Okay. Number 11, Justin. Awesome. Number 12, Annalise, I meant to say. Sorry, Alyssa. Well, I'm not working. I'm doing one at a time. Good. X over 12. All right. I'm going to learn Arwen for today. I got all these names in my head. Give me some time here. Questions. Jeremy, is this a question on this? Go for it. No. No. No, you don't have to do that. We're doing square roots. Are you right for what? You mean the square root of 112? Yes. Frodo. No, I'm okay. I got it. I just have to learn. I just don't want to mess them up. Frodo, you're good, unless you don't want me to call you Frodo anymore. I see like 200 and some students every day, so that's why you had to let me do one at a time. I know. Go ahead, Frodo. Because the 12 is not in a square root. It's by itself. Bless you. Okay? Annalise. Yep. What's the square root of 9? Yeah. You have to multiply those numbers first using the product property of radicals. 20 times 15 is 300. So then you take the 300 and you split it up into square root of 100 times square root of 3. Square root of 100 is 10. So basically, Annalise, you multiply the numbers first using what we did Monday, the product property of radicals, or Tuesday, whatever day that was. Okay, Manatee? Dr. Manatee? Okay. Anyone else on the homework? Anyone else on the homework? Okay, close your calculator. Shh, quiet. Donatus, close your calculator. Shh, quiet. Guys, girls, close your binder. Shh, quiet, relax. Do not flip this over until I tell you to. Hey, relax, Emma, relax. Calculator's closed. Do not flip this over. Your name, put your stuff away. Away. Throw it on the ground. Do not flip it over. Do not flip it over. Name on the back. I hope I'm making you nervous, Donatus. Hey, shh, relax, relax. Okay, let me get it passed out, okay? Relax. Okay, put your name, 6th grade, listen. Turn around, everyone face me. Put your name on the back. Relax, take a deep breath. Okay. Okay, whenever I say go, listen, you have a minute. Okay, no calculator. Guys, if my 9th graders can do this, you can do it, okay? Shh, I don't care, you're 2 years advanced. You can do it. Hey, I have high expectations of you. That's good, you can protest. When you get 100%, keep protesting. Okay, enough. No. Doug, yes. Yes, it's graded. Okay, 1, 2, 3, go. Do not put your name on it. Just do the problems. Don't waste time putting your name on it. You have a minute. Okay, quiet. All right, guys. I'm going to save the Pythagorean theorem lesson for Monday, okay? So I know you guys already know it. There's some other things that I need to add on. So let me go through the 9-2 extension lesson that I was going to do as Monday's warm-up. Let me, since we only have 5 minutes, let me talk through this with you. Don't write anything down, okay? I just want to have a conversation with you. Can someone remind us, what is a scalene triangle? Justin. Good. All the sides are different lengths. Briar, what is an isosceles triangle? Very good. What else do we know about an isosceles triangle? Dr. Manatee, you change your mind? Okay. Charles. Good. It has 3 sides, but what else do we know? Arwen. It's triangular. Justin. Good. It has 2 base angles that are the same. Okay. What about an equilateral triangle? Equilateral, Frodo. Good. All sides and angles are the same. Acute triangle. Doug, acute triangle. That doesn't tell anyone what that means. There we go. Okay. All the angles are less than 90. If someone doesn't know math, you got to make sure you're specific. What about a right triangle? Emma M. Good. There's one angle that's exactly 90 degrees. That will take us into Monday's Pythagorean theorem lesson, which, yeah, I taught you basically, but I need to get into more detail with you on that. Arwen. Good job. On the right triangle, both the other angles are acute. An obtuse triangle, Charles. Here's one obese angle. Oh, goodness. Okay, so give me a little more. Give me some more. What does that mean? If someone doesn't know math, it's fat. Hey, Doug. So it's more than what? Good, it's more than 90. All right, Dr. Manatee, go for it. Hey, go ahead. Just go ahead. She's not. Good. There you go. Good job. What about equal angular? Equal angular, Briar. Good. So if it's equal angular, Frodo, each angle is worth how much? Frodo. Good. 60. All right. So question for you. Is a right triangle, is a right sky, I can't talk here. Is this possible? Is it possible to have a right scalene triangle? Is it possible to have a right scalene triangle? Alyssa. Good. Why? Good job. Is it possible to have an obtuse scalene triangle? Is it possible to have an obtuse scalene triangle? Annalise. It is possible. But why? No, they don't have to be. Nope. Alyssa? Yep. So if it's an obtuse scalene triangle, one of the angles could be 100 degrees. The other two could be 30 and 50. And if that's the case, all the sides are different. What about an equal angular isosceles triangle? Is that possible? An equal angular isosceles triangle. Briar. No, it is. Charles, go ahead. Correct. It's kind of like the square rectangle thing we always talk about. If it's equal angular, it's also isosceles. Because the definitions of isosceles is two sides and angles are the same. All right, what about this? A right equilateral triangle. Is this possible? A right equilateral triangle. Doug, why not? Good job. Okay, homework. Page 463 in your book, for real this time. Just those 10 problems. Hold on, let me make sure that I agree with all those still. No, there will not be a pop quiz Monday unless those quizzes are disastrous. So I would still keep studying those perfect squares just in case. No, wrong book. Well, I didn't plan on that today, but we didn't have as much time as I thought we would. Yeah, just 1 to 10 on page 463. Do you guys feel better with simplifying radicals? Getting there? Okay. We'll do some more as a warm-up Monday. If you need to practice more of them over the weekend, the homework won't take long. So do some ones that are in the notes or on the homework, cover up the answers, see if you're getting better. If not, Monday morning, come see me so I can help you. Okay? So give me a thumbs up, thumbs up, thumbs down on simplifying radicals, just so I can see everyone. All right, thank you. Jeremy, what's up?